All right, everyone. Our next presentation here is Safeguarding Water Integrity Through Nutrients Reduction. And here to present is Harshit Peryagh. Harshit is an application engineer in training who has been with Nexom for almost 2 years. He holds a Bachelor of Chemical Engineering from Lakehead University and has been in the wastewater industry since 2017. Harshit previously worked as a laboratory technician analyzing wastewater and as a drinking water operator for the City of Thunder Bay's water treatment plant. Outside of work, he enjoys hiking, cooking, and playing soccer. Please welcome Harshit.
Thank you. Welcome to today's presentation. We'll be talking about how we can preserve the integrity of water through nutrients reduction. Thank you for the introduction. I work for a company called Nexom, which specializes in the manufacturing of wastewater treatment equipment. We deal mostly with the removal of carbon, ammonia, phosphorus, and nitrogens through the products shown on screen. Our main focus for today will be on the MITAC cloth filter and the sand filters, which are the Blue Pro and Blue Knight. Our company has been in operation since 1997, and we have several equipment installations across North America, as you can see on the screen. Coming to our main topic for today, which is water integrity. Water integrity, in other words, is just the overall water quality. The way we can measure it is through its physical quality, which deals with how clear or transparent the water is. Chemical quality, which deals with the amount of organic and inorganic contaminants in water. Third one is biological quality, which deals with the amount of microorganisms present in the water. And lastly, ecological quality, which relates to the quality of life of marine life, aquatic plants and animals. Why is it important to preserve water integrity? First and foremost, it's for our own health and safety benefits. We want to be able to go swim in the lake without having to worry about getting sick. Second one is to have a balanced ecosystem. Third one is to ensure we have sustainable development, thereby making sure that our next generation has access to clean water. Fourth one is for climate regulation. And the last one is to reduce the economic impact on industries that relies on clean water, as polluted water can seriously damage the business. These days, we have several challenges that are affecting the wastewater industry, thereby our water integrity. These challenges include excessive nutrients coming into the plant and with plants unable to treat it to a respectable level. Second one is the lack of water. Third one is the lack of efficient energy equipment available. Third one is restricted space. A lot of plants don't have space to add more equipment to the existing facility. The next one is operator shortages. I know when I was working as a drinking water operator, we didn't have enough operators to cover the 3 shifts at the plant. We had to work a lot of overtime, and I still think this situation is still going on as of now. And lastly, it's a continuous on-site monitoring. Most wastewater treatment plant has to have someone on site all the time, needs to have someone on site all the time to monitor all their equipment. The way we can preserve water integrity is by increasing water conservation, remove nutrients that are damaging our lakes and rivers, treat stormwater before it reaches lakes and rivers, thereby removing any nutrient and pathogen, by using energy efficient and compact equipment. Using maintenance-free equipment. When I say maintenance-free, I know when I was an operator, I didn't like to break pumps, clean several equipment on a daily basis. So having a maintenance-free equipment is crucial to a lot of wastewater treatment plant. And last one is making use of long-lasting equipment. Most equipment usually now has a lifetime of 5 to 10 years, but increasing the lifetime of an equipment will help preserving water integrity by not by preventing downtime in a wastewater treatment plant when changing equipment. While there are several solutions that can be used to tackle those problems, today we'll be focusing on the Mitre cloth filter and the sand filters, which are the Blue Pro and Blue Knight. We can install, this is a diagram of a typical wastewater treatment process. We can install the sand filter only on the tertiary level of the process, while the Mitre cloth filter can be installed both on the tertiary side and primary side of the wastewater treatment. The Mitre, when I refer to Mitre cloth filter, this is what I'm referring to. It's a disc filter that is used to remove TSS, which in turn has several benefits such as BOD removal, increasing the efficiency of UV disinfection, and it also increases the satisfied criteria for water reuse and potabilization in drinking water plant. It can also be used to remove phosphorus after coagulation and flocculation, and to capture microplastic and any emerging contaminants of concern. The cloth itself is made up of a polyester fiber on a polyester net. The cloth is made up has some passages hole that allows water to go through and solids to stay on top of the cloth. At Nexom, we have 3 types of cloth. Sila 500, which has a pore size of 5 micron. The Sila 1000, which has a pore size of 10 micron, sorry. And the Sila 1500, which has a pore size of 15 micron. Next, if any one of you here knows where the word Sila originated from, please raise your hand. It comes from the Greek mythology, which refers to a creature that used to trap sailors in its tentacle. Now let's move on to how the disc filter works. It is an outside-in gravity filter, and it is a fully submerged cloth filter. As you can see in the picture, the whole filter is covered underwater during its operation. The way it works is a bit simple. As the tank is filled up with water, the water flows through the cloth and enters a central tube. As more and more water flows through the cloth, 30 solids deposit on the cloth, and as the cloth gets clogged, the water level rises until it reaches a set point. Once the set point is reached, what we call a backwashing cycle is started. During this cycle, the solids on the surface of the cloth is captured or sucked in by the backwash shoe, the black tube on the cloth, and the disc rotates in one direction as the solid is being captured. During backwashing, filtration is still occurring. As you can see here, the backwash shoe has a nozzle that is capturing all the solid as the disc is moving through. Depending on the size of the filter, we can backwash clusters of discs, up to 4 discs at one time. From a PNID perspective, we can see that dirty water comes into the tank, the water level rises, it flows through the cloth, through the effluent channel. As the cloth gets clogged, the water level rises until it reaches the set point, and what we call a backwash starts, and it cleans all the solid from the surface of the cloth and send it back to the headworks. Occasionally, we'll have a sludge pump that will turn on to remove any sludge that might have been accumulated in the tank. One of the key benefits of the MITRE filter is backwash mechanism. Can you click play on the picture, please? During backwashing, we are able to remove a lot of solids, but most disc filter can only rotate in one direction. The filter here can rotate in two directions. By doing so, we're able to reduce the backwash frequency, backwash time interval by 20 to 40%. We're able to extend the time to perform chemical cleaning by 50%, and depending on the use of the cloth, we don't need to perform a CIP clean up to 2 years. By doing so, we increase the life of the cloth. Usually, a cloth lasts 7 years, but by doing both clockwise and anti-clockwise backwashing, we're able to extend the life of the cloth by 10 years. So in some cases, even more. When we look at the backwash, one analogy I like to refer to is as carpet cleaning. When we are cleaning a carpet, we don't just go in one direction. Usually we go in both directions, because if we go in one direction, we won't be able to pick up as much solids as we do when we go in both directions. This is the same analogy that applies to the cloth filter. Here are some examples of what it looks like. On the left-hand side, you can see a disc filter in stainless steel tank and in concrete tank. Usually, it is maintenance-free. We don't have to do it. Once it starts, we don't have to worry about it. We just have to walk around every day 10 minutes to check if everything is working. And in case of maintenance, we can just walk on the platform. If you look at the second picture from the left, you have a platform. Everything can be done from the platform, removing the disc or the backwash pump, the blue backwash pumps. Everything can be done on the platform. On the right-hand side, you have a vertical orientation filter, and everything is done on the platform, on the concrete pad itself. We have a maintenance opening on the tank that you can access and change all the discs and components if needed. This is how it looks like from factory. Everything is shipped as you see in the picture. We just have to, when it reaches its destination, we just have to drop it in and connect the tubes for influent and effluent, and that's it. We have installations all over the world, such as Italy, UK, and California, as seen in the picture here. The first picture you see is the largest disc filter plant we ever had. It's a 16 filters of our largest filter, which is 32 disc. We can manufacture, depending on the required flow, we can manufacture disc filter from 2 discs to up to 32 discs. The next technology that we are using to preserve water integrity is the sand filter, which we refer to as Blue Pro and Blue Night. We use it to remove phosphorus and nitrogen in form of nitrate. The sand filter is able to remove phosphorus to up to less than 0.02 milligram per liter TP and less than 500 milligram per liter TSS. For nitrate, we're able to remove up to 1 milligram per liter nitrate. The sand filter can also be used to remove heavy metals such as copper, lead, and mercury. What's fascinating about this technology is that in one vessel, we are able to do both nitrogen removal and phosphorus removal. The sand filters are also referred to as a continuous backwash filtration. And this is due to the fact that they're able to continuously regenerate their media. That is, once set up, we don't have to remove the sand or add any other media. It is continuously being used, and you can use it for a long time. The lifetime of a sand filter is about 15 to 20 years. When it comes to low limit phosphorus, a lot of plants struggle to meet ultra-low TP limit. And the reason why the sand filter is the most efficient is because it uses reactive filtration, which coats the sand, and the sand acts as a binding agent for the chemical. By doing so, we eliminate the need for flocculation. We don't require, if you're using a sand filter, we don't require flocculation, compared to the disc filter, where if you want to remove TP, you need to have coagulation and flocculation in the front. This is how typical sand looks like for the sand filter. It is a special type of sand that has a special porosity and size. And as I said before, compared to the conventional coagulation filtration, we don't require coagulation flocculation. The way the sand filter works is, while it looks complicated, it's actually simple. When we set it up, we clean the tank and clean the sand, fill it up with water. As soon as we fill up the tank, we start the airlift. The airlift will take the sand that is trapped at the bottom up to what we call a wash box. Once everything looks good, we add chemical dosing to the sand. The chemical will stick to the sand and act as a binding agent for the contaminants. So you can see here, the green water, which is the dirty water, goes down. The coated sand picks up contaminants, which is black, and it goes up into the wash box. In the wash box, the coated sand is cleaned up due to the impact the coated sand separates from the contaminants, and the sand flows down through what we call the tortuous path, which is the black component at the top. When it comes to the blue for nitrate removal, the sand media acts as a surface for bacteria to grow. And instead of chemical, we use micro-C as a carbon source for bacteria to feed on. The sand filters can be installed in FRP tanks or in concrete. It can be installed in single stage or dual stage, depending on the requirement needed. This is how a typical sand filter looks like in FRP tank, and the top picture shows how it looks like in concrete. This is again a maintenance-free equipment. We don't have it starts. We don't have to touch it. We just have to watch everything from the control panel, and that's it. If anything wrong that happens, we get alarmed from SCADA. One way we were able to use the sand filter to preserve water integrity is in Alabama, Citronelle, Alabama. They had a TP limit of 0.02 milligram per liter, which is one of the most stringent TP limit we have in North America. And we had to use a dual pass setup to treat phosphorus. If you look at the graph here, before the Blue Pro, they had a TP limit from a effluent TP from 2 to 3.5, but as soon as we commissioned the Blue Pro, the TP level dropped down to less than 0.02. Okay, there was some issue that happened before due to unseen circumstances. The TP level rose, but once everything got fixed, the TP level dropped down. This is how the setup looks like, and this is the effluent that comes out of the Blue Pro. Thank you for your attention. I'm happy to take any questions you might have.
Any questions in the room? Anything online, Heather? Okay. All right, well, thank you very much, Harshit.